Hey everyone, and welcome. Today we're going to dive into something pretty amazing, that invisible energy that's, well, everywhere. It's in the food we cook, and it's even in the air we breathe. Let's get into it. So, have you ever really thought about this? Like, why does cooking an egg change it forever? You can't uncook it, right? Or how about this? How does eating lunch suddenly give you the energy to get through the rest of your day? It's not magic, I promise. It's just some really cool chemistry at work. Yep, the secret behind all of it is chemical reactions. Seriously, they're like the engine of the entire universe, always changing things from one form into another. Okay, so what even is a chemical reaction? Let's break down the basics real quick, because that's going to lead us to the really fun part, the energy. So at its core, a chemical reaction is just atoms getting rearranged. Old bonds between them break, new bonds form, and poof, you get totally new stuff. But here's the key thing for us today. Every single time that happens, energy is either let out or sucked in, and that energy transfer is what this is all about. All right, let's start with the dramatic ones. The reactions that release a bunch of energy, often in a way you can really feel. We call these exothermic reactions. And here's a super easy way to remember it. In an exothermic reaction, heat exits. Get it? These are the reactions that warm everything up around them, just like a good campfire. A perfect example you see all the time, burning fuel. I'm talking about the gas in your stove or a backyard barbecue. Let's take a quick look at the science behind it. On the left side, you've got your starting stuff, methane and oxygen. And on the right, you get the results, carbon dioxide, water, and here's the important part, heat. See how heat is a product? That means energy is being released. And that's the heat that cooks your dinner. But hey, these reactions aren't just for stoves and campfires. Actually, one of the most important exothermic reactions ever is happening inside your body, literally right now. It's respiration. See, your body takes glucose. That's the sugar you get from carbs like bread or rice, and it mixes it with the oxygen you're breathing. And what do you get? Carbon dioxide, water, and the energy that lets you walk, talk, think, everything. Your body is basically a tiny, slow-burning furnace. Okay, so we've got the reactions where heat exits. Makes sense. But what's the opposite? What about reactions that actually need to absorb energy to even happen? Let's check those out. And that brings us to our second type of reaction, the kind that actually makes things around them feel colder. We call these endothermic reactions. And just like before, there's a trick. For an endothermic reaction, heat needs to enter. See? It has to absorb energy from its surroundings, which is exactly why things like instant cold packs feel so chilly when you crack them. A really classic example of this is something called thermal decomposition. Sounds complicated, but it's really just a fancy way of saying using heat to break something down. This really shows how it works. You start with limestone. It's just a rock, right? It'll sit there forever. But if you add a ton of heat, in other words, if energy enters the system, it'll break down into two new things, quicklime and carbon dioxide. Notice that heat isn't something that comes out at the end. Nope, it's an ingredient you have to add to make it go. And maybe the most important endothermic reaction on the entire planet is photosynthesis. I mean, think about it. Plants take in sunlight, they absorb that energy to turn carbon dioxide and water into their food. Without this incredible energy-absorbing process, none of us would be here. So, what's the big takeaway? These two types of reactions, exothermic and endothermic, are happening all around us, all the time. They create this amazing energy cycle that pretty much runs the whole world. So let's do a super quick recap. You've got your exothermic reactions, the ones that release heat, like burning fuel or even your own body's respiration. Then you have the endothermic ones, the reactions that absorb heat, like decomposition or photosynthesis. It's this incredible balance, right? Plants absorb the sun's energy, and we release that energy to live. It's a perfect cycle. And that just leaves us with one final question for you. Now that you know what to look for, where else do you see this happening? What other reactions around you are heating things up or cooling them down? From a sizzling barbecue to an instant cold pack, once you start looking, you'll see this amazing chemistry is absolutely everywhere.